Okay, this question comes from June 2006, Module 4, Question 2, and again it's a gas laws question. The formula sheet gives us PV equals a third nm c squared brackets. State what the product nm, well, n is the number of molecules, m is the mass of the molecule, so n times m represents the mass of gas. Okay, so that's the mass of gas that there is. Okay, so it's the total mass of gas. The quantity c squared brackets is the mean squared speed. Explain in words how you would calculate the mean square speed. Well, in order to calculate the mean square speed, the first thing to do is square each value of c. So we take each value of c and we square it. Then we add up all these squared values. We then divide by the number of molecules. And that will give us c squared brackets, c squared mean squared speed. So we square each of the values of c, add up all these squared values, divide by the number of molecules. So it's c1 squared plus c2 squared plus c3 squared plus c4 squared plus all the way up to cn squared, and then we divide by n, and that gives us this mean squared speed. Okay. The formula sheet then gives us this half mc squared brackets equals 3 over 2 kt. And we've plotted a graph of the kinetic energy E of K against the Celsius temperature. Now this is important because this is the Celsius temperature and this is the Kelvin temperature here. So we remember then we could rewrite this and say that a half m c squared brackets is equal to 3 over 2k times, and then that would be 273 plus theta whenever we're looking at that. So that is why we get a graph which has got an intercept, because we have an equation now. So this is E, so the equation for this really is that EK is equal to 3 over 2k theta plus 3 over 2k times 273. So that's what we've essentially got. And this is of the form y equals mx plus c. So this is c, so the intercept here, okay, whenever we look at this intercept here is 3 over 2k times 273, and the gradient is 3 over 2. Okay, so the gradient is going to be equal to 3 over 2k. Just from up here, that's y equals mx. So obtain numerical values for the gradient and energy of this intercept. So the gradient, we've said, is equal to 3 over 2 times k, and k is 1.38 times 10 to the minus 23. So that means that the gradient is equal to 2.07 times 10 to the minus 23 whenever you work that out. Okay. And then the intercept is going to be equal to 273 times that 2.07 times 10 to the minus 23, which is equal to 5.65 times 10 to the minus 21 when you work that out. So we have a gradient equal to 2.07 times 10 to the minus 23, and we have an energy intercept of 5.65 times 10 to the minus 21 joules. Final part of this question is that one assumption of the kinetic theory is that the collisions of the molecules are perfectly elastic. Describe and explain what would happen to the gas if the collisions were inelastic. Well, if inelastic collisions means that the kinetic energy would not be conserved. And so, as a result of that, the molecules would slow down. And if the molecules slow down, the temperature would drop. And the pressure would also drop. Now, if it's an inelastic collision, kinetic energy is not conserved, so kinetic energy after doesn't have to be equal to kinetic energy before. Some energy would be lost in the collision. That would mean the molecules would slow down. Because the temperature is proportional to the kinetic energy, if the molecules slow down, the temperature goes down. Because the pressure depends on the number of collisions per second, there would be less collisions per second, so the pressure would drop. So that's all in that particular answer there.